to be in the superficial femoral artery at the beginning of the procedure. The correct entry point can be located either by fluoroscopy or ultrasound, and is approximately 5 centimeters above the profunda artery in the common femoral artery. This is important, as an entry point which is too proximal will make it difficult to control bleeding, while going too far distal will make it impossible to go into the SFA. Carefully advance the Terumo guide wire down the vessel towards the lesion, following with the catheter once the lesion is reached. The tip of the wire will encounter resistance and move towards the wall of the vessel as further push is applied from the base of the wire. Follow the wire with the catheter and bring up to the vessel wall in order to provide purchase for the catheter to support the wire most effectively. This will assist the wire entry into the subintimal layer. Further push will make the wire loop back onto itself. This loop is crucial. It provides a safe progression of the wire through the subintimal layer with a low risk of sectioning the vessel. Advancing the ReeKross through the subintimal layer just behind the loop will prevent a spiral building and will provide additional support to go through highly calcified lesions. The loop will extend until its furthest point reaches the end of the occlusion, where lack of pressure from the intimal layer and continued pressure from the outer wall will induce the wire to slip back into the true lumen of the vessel. It is believed that the forward pressure required to continue through the intimal layer at this point is higher than the force required to re-enter the lumen. This point is clearly visible on the screen as the diameter of the loop reduces when re-entering the vessel to adjust to the smaller vessel diameter. Once this point is reached, the catheter can follow along the wire in the subintimal layer in order to place the balloon alongside the occlusion. The progress of the catheter along the wire will allow the operator to undo the loop and park the wire along the artery beyond the occlusion. Once the balloon is in place, at the most distal point in the lesion, it is inflated once or several times, pushing the calcification towards the lumen wall. The number of inflations will depend on the degree of calcification. In long lesions, the balloon can be pulled back into the more proximal parts of the lesion and inflated again. This is repeated until the occlusion has been fully ballooned. Once satisfactory blood flow is established, the catheter and wire can be retracted. The vessel is now allowing blood to flow freely.
The strength of the ReeKross catheter in combination with the flexibility of the Terumo wire, as well as their availability in 0.18 and 0.14 sizes, also makes it possible to carry out successful intervention in seriously calcified lesions below the knee. Their strength and pushability make it possible to advance well into the plantar arch with full control of the wire and without the need to pull back the catheter in order to inject contrast. As a result, cases which would have been considered not suited for endovascular treatment beforehand can now be treated successfully, and that with avoiding limb loss, even in difficult cases with highly calcified lesions.
The ReeKross is also available in 0.018 and 0.014 guide wire platforms, suitable for severe cases in narrow and distal vessels. Balloon lengths of up to 22 centimeters are also available for treatment of very long lesions with a minimum number of inflations. The pushability of the ReeKross platform makes such balloon length a realistic option.